This is James Ball of the Hacking Beavers group. In the previous video, I demonstrated how to find a static address for mana and set a goal that our team should be able to write a simple hack to modify the mana value without using something like Cheat Engine. We managed to get this done by modifying a hack for another game written by Rake on the Guided Hacking forums. Let's walk through the code. The core of the external hack revolves around three main functions, the first of which retrieves the process ID. First, we pass the name of our target to the function. The function takes a snapshot of the processes in memory. It then loops through the processes in memory, looking for a match. When one is found, it breaks the loop, the snapshot is closed, and the ID is returned. The next function mirrors the first one, except it takes the process ID as an argument and aims to return a base address. So it'll take a snapshot of the modules in memory, loop through them looking for a match, breaks when one is found, and returns the base address. The last function, findDMA_address, helps us to find the target variable within the process. It does this by accepting a vector of the offsets to get to the static address for the target variable. These were found using Cheat Engine with the methods explained in the first video. So here's our mana pointer, and here's our list of offsets that we need to follow. In the main function here is where we actually go through the process of passing along the name of the function we're looking for, what we want the new value to be, and where to find the target variable within the program. So let's run this thing and see it in action. Here we've got our mana set at 100, which is the default. And let's run the program. And so there you go. It found our base address. It found the address in which our mana is stored, what the mana was, and what we want it to be. And we can confirm with Cheat Engine that yes, indeed, that is the correct mana address. That's proof of concept, good news, but let's talk about the bad news and why this isn't mission accomplished. Remember that we wanted to build a trainer to modify in-game values on the fly. At first glance it looks like this method could do it, but remember that our team has only managed to find the static address for mana. Now in the game Assault Cube we see how structures are set up that control weapon behavior, we found the pointer to player attributes, and we know the offsets to these variables, so we could change them using this method. But our target game, Pwn Adventure Pony Island 3, is built differently, and the classic methods of hunting down static addresses aren't working. I've tried pattern scanning, observing memory in real time, guess and check with a debugger, and I'm still stuck with just mana. So our next step is to try and reverse engineer aspects of the game. First off, I want to credit Xiao in our group for finding the tool Scylla to help out with this portable executable dump. I've loaded this tool as a plugin into x64 debug. As I understand, reverse engineering any sizable program is a difficult and time-consuming task, and I'm very much in a state of learn as I go. I've got two action items to address by this time next week. First is to go through this list of potential functions and compare it to the Unreal Engine source code. Hopefully a better understanding of the architecture gives us a better idea of how we can hunt for specific processes within the game. Second, and more personal, is that I think I need to better plan out how to allocate my time on this endeavor. I've lost many hours trying to follow chains of addresses in RAM looking for a static pointer. In retrospect, I think had I used that time to better understand some of the tools that are purpose-built for hacking games or reverse engineering, then I'd be much further ahead on mapping out the target variables.